YouTube! Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video now and answer them. I'm also going to include the questions for Friday. For Friday, we'll have some ionic bond practice too. We haven't done that in a while. Okay? Next, can you go to the slides? Thursday. Ionic versus covalent bonds. We're going to go over this. It's been a while since we touched on ionic bonds, and ionic bonds will be on the final, so I want to go over them again. And I just posted the retake for the ionic bond quiz, so I'm going to go over them for that reason too. So remember, the definition of an ionic bond is made when a metal moves its electrons to a non-metal, and the one that lost its electrons will be positive, and the one that gained an electron will be negative. And that's why ionic bonds work, is because the positive and negative are attracted to each other, because opposites attract. Next, so remember we did the process of taking a definition and making it a little bit more simple in your own words. Now I want you to try and do it yourself with a covalent bond. Okay? Then I just want you to remember there are differences between covalent and ionic bonds. Covalent bonds are only with nonmetals. So covalent bonds, we're really going to focus on them with the nonmetals. So really covalent bonds are going to focus on the blue. But know this column, we really won't use this column at all. The reason why, this column, they all have a full orbital. Helium has a full orbital with 2, and the rest have a full orbital with 8. So, since they're full, they're not very reactive. They don't need to gain or lose any electrons to be happy, so they are very unreactive. So covalent bonds will really deal with all the nonmetals, except for this column, the noble gases. But ionic bonds are a little different. Ionic bonds use a metal, so one of the red ones, with a non-metal. Covalent is about sharing electrons, whereas ionic is more about giving them up. Both bonds find a way to help the element be stable. By having a complete orbital, they're just two different ways to do it. Okay, so here's some review. You should be comfortable using the periodic table and figure out how many valence electrons each element here has, and then predict which ones will make an ionic bond. And then I have some review. Which of these nonmetals will lithium want to make an ionic bond with? And then tell me how you figured it out in the second blank. Next one, this one's going to be a little tricky. So I want you to attempt it first by yourself and pause the video. Okay, so it says sulfur, S. How many valence electrons? So remember, it goes by column. So the first column, this is all 1. The second column, these are all 2. Transition metals skip. This column, all 3. This column, 4. This column, 5, 6, 7, and 8. Sulfur is right here. So if this is 8, then that's 7. And then sulfur is in 6. Okay, so sulfur has 6 valence electrons. That's very important. What are 2 elements that sulfur would make an ionic bond with? So, sulfur has 6. Remember, ionic bonds are all about getting a full orbital with 8. So, if sulfur has 6, it's going to look for an element that has 2 valence electrons, because 6 plus 2 equals 8. So, any of these elements in this column would give sulfur a complete orbital. So you could say Be, Mg, calcium, strontium, barium, radium, any of those. That entire column would work. This one's a little trickier. What are 2 elements that sulfur can make a covalent bond with? So you have a lot of options for nonmetals for sulfur, so I would have taken any of the nonmetals except this column. Remember, this column, unreactive, so they're not going to make a covalent bond because they're already happy. So you could have said oxygen, phosphorus, chlorine, hydrogen, any of those nonmetals, except the last column. Okay? Next, if you got chlorine earlier, you would have been right. So let's say lithium gives its electron to chlorine. What's the charge of lithium going to be? And what's the charge of chlorine going to be? Last one is some covalent bond practice. This covalent bond is going to be very large. That's why I give you so many dots. Okay? I'll give you a hint though. It's going to look very similar to ammonia, NH3. Okay? Phosphorus is the central atom because there's only one phosphorus. Okay? That's my hint for the last one. Once you do all those, please turn it in and take the survey for Thursday and Friday. And when you're ready and feel good about it, take the Ionic bond quiz. That's the last thing. Thank you so much, everyone. Have a great week.